Hello friends, I'm going to make through a walkthrough to show you how to generate a text using keywords. I am using IPython notebook. So here would be generating a random text from an into a IPython notebook by just reading a text file. So let's start what all I have used. So we have started by importing the classes and the function we intend to use to train our model. So these are the functions and the classes we have imported to just train our models. Moving ahead, next we need to load the ASCII text file for the book into the memory and convert all the character to the lower case to reduce the vocabulary that network must learn. So I have read this file. This is a comic book and it is in a text file. So I'm reading this file into a raw text and making it convert to the lower character. Now the book is loaded. So we must prepare the data for modeling the neural network. We cannot model the character directly. Instead, we must convert the character to integer. As we know, the computer only understands the numeric language. So we can do this easily by converting we can do this easily by first by creating a set of all the distinct characters. This all the distinct characters I have created. This creates all the distinct characters, and in the book then creating the mapping of each character into a one hot coding. So this is how we have created one hot coding. Moving ahead, I am summarizing the loaded data. So I just want to calculate how many characters are there in my raw text file. So the total characters are 163817 and the number of vocabulary, that is the unique characters which I have got it. That is the characters length of the length of the distinct characters which I got in my text file is 61. So we can see this the book has just 163817 total number of characters. So as now we would be splitting the data into training and the testing part. So you can see I have created a sequence length that is 100. So sequence length is basically that creates a sentence where I would be having 100 characters in a sentence. So running this code, we would be getting we would be splitting up the data set into training data for the network. This part is the training network and the other is the testing part. So this makes sense as excluding the first 100 character. We have one training pattern to predict each of the remaining characters. The 100 is the excluding part of the training set. So we would be predicting rest of the part. So moving ahead, I have normalized the data. So finally we would convert the output patterns, like the example is like an integer. So in this one hot coding, if you are predicting a character A, so the one hot coding creates this character as a unique number such as 2, but then which is like the one hot coding converts is into a bit form 0001. So this one indicates it's a 2, and the two value which has been converted from character to int is A. So computer is like working on numbers. Number has been converted into a unique integer, and then it will be again converted at the output part to a character. So now we can define our LSTM model. This is our LSTM model. I'm defining my LSTM model. I would be explaining how it works. So now I have defined our LSTM model. A single hidden layer. I can say it's a two hidden layer. I have added two hidden layers in this with the 256 memory unit. This is a 256 memory unit. The network uses dropout with a probability of 20%. The output layer is a dense layer using the softmax activation to the output of probability prediction of 47 characters between 0 and 1. So moving ahead, the network As you know, like the LSTM is the slowest network to train around. The network is very slow. It took about 15 minutes per epoch on my system. I have a GPU system. I'm using NVIDIA GTX 1050. So because of the slowness and because of our optimize require, we will use a model checkpoint to record all the network weights to file each time an improvement in loss is observed at the end of the epoch. We will use the best set of weights to initiate our generative model in the next section. So this is where I have like saved the file, given the name of the weight file, which can be weights LSTM. You can give any of the name. This would be this would be giving the epoch number, and this would be giving me the loss. So I have saved the file into my workspace, and by fitting, I am running the fit model. Now we can fit our model, right? This model has been fit of the data. Here we use a model number for 80 epochs and the batch size is 64. I have like created, I have already run because it took like 18 hours to run me. So it's like ways to run in while recording this because it will take more time and it's gonna hang up my videos. So you can see I have saved the weights as the weight is improved. Here it was the loss was 1.46. Now the loss is 1447 and so on. I have like saved the improved loss. So the last loss I can save is like 1.3864. You can see it over here for the epoch 48. So I have like manually stopped this. So in this part now we would be just running our code to show you like how the text has been generated. So I have run this code. As you can see, it has been generating. Here you go. I know this model is not that accurate because like it takes more time and I have just ran for 80 epochs and my characters are also very less. So you might be having some issues like, okay, why it's not getting me the good grammatical. So we can solve this grammatical issue by adding more epochs, and we can train the model on the padded sentence rather than random sequence of the character. Increase the number of training epochs, as I said. You add the dropout to visible input layer. Predict the fewer hundred thousand more, like predict less than 1,000 characters. I'm here like I'm predicting only 700, I guess. Okay, I'll just run it again. Every time it generates a unique characters. By this we can also generate the Wikipedia text. So here's the short example how I can say you that, okay, the random text is been generated which can be more categorized in a different way and improve in a different many other ways. So this is my short presentation. Thank you.